Hi guys, I hope you're good since last video. This video could be actually 3 different videos, but I wanted to have all in one video as we are talking about the same topic and might be confusing if not following an example flow. So we will be going gradually and using some concepts that we have seen before, like affinities, so that it becomes easy for you to use those. In this video we will be talking about storage in Kubernetes, the persistence of storage. We will see what are the clusters assumptions when using those options, what is needed to be activated to easily manage storage, and how it works overall. So as it is a long video, plug your computer closer to the fridge or bring a mini fridge next to you to not fall apart, and pause the video to see some details. At the end, the timestamp is different, as I had to redo the examples to show you one more stuff for the people staying until the end. I've left a link in the bio for the students who want to learn AI by doing, beginner devs who want to think at a service they could offer, or business owners who want to use AI for themselves. It is free. There is a guide PDF to download on the video. Link is in the pinned comment or video description. Get it now from our hub, Shaker Houses. Also, please like and subscribe. Thank you for your support. Open your terminal. Let's get started. A higher level view, just a little explanation. So the top part is the ideal zone. Unless pod is requested, nothing happens. The resources, the pod downstairs, which is going to be requesting those pods. So we have a storage class defining the provisioning, static or dynamic, PVC's persistent volume claim, storage class name would be referenced here, and the storage required. The pod will use the persistent volume claim to request some storage capacity. And the PV, a persistent volume, is mounted then to the pod. Okay? So storage class get this persistent volume, the actual storage, dynamic or static, and the pod will be able to use it, will be connected to it. That's how the pod gets his persistent volume. There is a static way and a dynamic way, and we will start the video with the static way. Storage class, persistent volume claim, persistent volumes on the top, and we have the pod requesting those. Just keep this in your mind. Come back to this part during the video. We start with the static way of getting persistent volumes. We're going to go slowly, step by step. The first part of the video, half of it, is going to be about the static way, and the half, the end, from the middle to the end, will be about dynamic. It's very important to see the steps, how we're going step by step further. I'm using some options. It's very opinionated the way I'm doing it, because I want to show you just one example flow so that you understand it the way I want to translate it. So we're going to create here a file called StorageClass wait for first consumer, which is an option that I'm going to, during the video, activate and deactivate sometimes. So let's create the YAML file together. We have the API version of this storage class. So this is in the higher level diagram that I showed you, the one on the top. So we're going to define that first. Storage, Kubernetes, IO, the version 1. The kind is a storage class. The metadata, the name. For the moment, we're not going to play too much with the names. After, we're going to jump into our Japanese names. So the name here is local storage. Volume binding mode. So this is the option that we're using here. Wait for first consumer. Okay. We need also a provisioner. So when you're working with a kubeadm cluster, you don't have any provisioner. So you basically use kubernetes.io/no provisioner for that, okay? So this indicates that this storage class does not support automatic provisioning. So that's why here we, in the static side of the way of making those volumes, persistent volumes. So when using this provisioner, it indicates that this storage class doesn't support automatic provisioning, so not dynamic. So this option here, we're going to be turning it off and on. So we will check with and without this option, okay? And we will see how the cluster responds. So here I'm going to save it, leave this option activated, the volume binding mode. So the way that the volume is going to be linked. Wait for first consumer. Let's edit another file, which is going to be, we had the storage class on the top, and after under it we have the PVC, which is the persistent volume claim. And here we're going to be creating a file called PVC without selector. Because if you want, you can also use here a selector, as we've seen in the previous videos, with a node selector label, to select a label, or using the affinities. Affinity, we're going to be maybe using that one in this video. To not confuse you, we're not going to use selectors everywhere. We're going to use just in one resource at a time, so that you understand how those pods are affected to certain nodes. Just using it like that, so we can link what we've done before and keep learning new concepts. So here the API version is 1. The resource that we're creating here is a persistent volume claim, metadata. The name here, I'm going to use a long name just to say. That's a persistent volume claim scheduled in node affinity defined by the persistent volume, because I'm going to define the affinity in the persistent volume. This resource, the persistent volume claim, is a namespaced resource. So here the spec, the access mode, RWO. So because we're working with a local cluster, we're going to use this option here. There are several options that I invite you to look at through the documentation. So here it's read, write once, which means that the volume will be created in only one node with a read and write access. Volume mode, file system. So here we're going to use the file system. That's what we want. The resources, the requests. So here we're going to request some storage. We're requesting 512, I would say kilobytes is KI here. So it's based on 1024 bytes. Okay. And that's how you're going to be referencing it here. So here it's half of 1024, 512 that I'm going to be requesting during this video, as I have a small cluster, limited one, and we want to avoid those errors. So start small, and depending on the resource, the pod, and what it needs, you'll be able to use different sizes. That's why you understand that in the upper level we have a storage class referencing those different kind of storage. You can be creating the storage based on the size that they represent. So here I'm using storage class name. We're going to reference the storage class that we have used. We will be playing with that also. Okay, so local storage, that's the name of it. The selector, you could have a selector here if you want to have a fine-grained control on where the resources are deployed by the scheduler. But here we're not going to be using that, but I just show you in the comments that you can be using it here. Okay. So that's the name of the PVC. Access mode, read write once. So just in only one node. The file system is the volume mode. Okay. And we're going to be requesting some storage. File system. Just going to be writing here in the comment that it's read write on volume in one node. Okay. Let's write this file. Okay, this is saved. And now we're going to do the next that we need. We're still in the upper part of the diagram. We've done the storage class. We've done the persistent volume claim. Because here we're using the static way of doing the persistence of volume, we need to create our own persistent volumes. Persistent volumes. So here, API version 1, the kind is a persistent volume. That's the resource that we need to create. When it's static, you need to create this persistent volume. It's very important to understand that. The metadata, we're just going to give it the name here. Local PV, persistent volume, with mandatory affinity selector. So the affinity here is mandatory to set because I will be using local. I will be using the option local just to use the file system as we work in the local cluster. And at the same time, I find it cool because you'll be able to see the affinity. So the capacity, the storage 512, we're going to match the other capacity, so it's going to be affected to that one. Okay. The volume mode is a file system. It can be also block if you're using SSD. Block storage. I assume that SSD works with that. So here we're just going to be using a path on the node, so the file system. The access mode will be the same. Read, write once. Okay. So single node mount on all pods on that node can read and write. Just to precise what we've said before. So RWO will get the volume in a read-write mode in one single node. And on that node, all affected pods will be able to read and write to it. after persistent volume reclaim policy. So let's put a capital P here, using the camel case way of writing it. And here I'm just going to use delete. So here you have different options. The default option is retain. Retain means, I'm just going to write which is the default. Okay, so retain is going to be keeping the persistent volume on the node, while delete is going to be deleting the persistent volume. But we will see that what's going to happen on the node. Is it deleting it from the cluster, what the cluster can see, so which resources are present in the cluster, or is it physically deleting it, deleting the path that has been created on the node? So that's the whole purpose of this video, is to see those little details that makes the difference. The storage class name, we're going to also reference the same storage class name, which is local storage. We have created one. And here we're going to use the option local in order to provide the path where we want our persistent volume to be created, to be living. So we're going to use the temp folder, and the temp folder we're going to call it local-pv. So here, when using local option, just to say that it is mandatory, we must set node affinity. Okay. Because we must tell it where this path is present, because we're using static way to make those persistent volumes. So you want to have a full control. So at this time you need to be more precise in your directives. Okay, I'm just going to separate the different parts of this YAML file so that you can see how it is composed. Capacity, volume mode, access mode, the reclaim policy, and we have the storage class name, and after here we use the option local with a node affinity that we're gonna define now. So that's what we've seen before, the node affinity, which is gonna permit us to have this fine-grained control in where the resource is going to be allocated. And you will see here that it will have to match, otherwise it won't be allocated, because the persistent volume itself is not namespaced, or you will see. I'm not going to tell you everything, but here I'm just going to show you required. After we need node selector terms. Okay, so in the persistent volume, that's how you're going to define the node affinity. While in the pod, when you define the node affinity, you need an upper level key, which is called affinity, and put everything inside. And instead of required, you would use required during scheduling, ignored during execution. So it's a longer sentence, while here you just put required and you don't need to key affinity. So here we're just going to match the expression. We're going to use a key, which is going to be called location, and the value Shizuoka, which is a Japanese city. soccer city. And we use the operator in. Okay. So when using the static way, this is a very important file. This one, the YAML file that we're doing now, the persistent volume one, because it's mandatory to create it manually. But here I put storage class like that, because we will be playing with that also, changing the storage class to nothing, to an empty string. Okay. So we have here location key, value Shizuoka for the node affinity. So we're going to go to the terminal. Just to not forget to do it, we need to label this node. So let's get the nodes. We show the labels. Okay. Just check if I have cleaned up those labels. Node 2. So let's select the node 2 to match the affinity there. So key label node 2, node 2 Creditizens.net. And we're going to create location. We said Shizuoka. Try to not make any typos. Okay, so has been labeled, confirmed. That's good. So now that we got all the upper part of the diagram, which is not doing anything yet, we're going to now create the pod itself. So at the time the pod is going to be created, is going to be requesting a persistent volume. So it's going to pass through a persistent volume claim, which is going to go and get the storage class. Storage class is going to check the available persistent volumes that you have created manually. Here I just create one of each, but there might be several persistent volumes. See the one matching the requested capacity, and after it's going to be trying to bind it to the pod. Just trying to resume here what might happen, and if we get any errors, we're going to explain why and see how we can troubleshoot those errors. So API version 1, the kind is a pod, the metadata, the name, we call it pod needing storage. We use the spec, the container, so containers, just going to use one container. So now you might be a professional of indentation in YAML files. The name, I need storage pod. We're going to use Nginx as an image. The volume mount. Volume mounts, we're going to use mount pass. So temp, local PV. The name, I'm going to call it my local storage. Let's make it easy. So container, volume mounts, mount pass, and now we need the volumes. In terms of volumes, just give it a name, which is going to be the same, my local storage. Okay, and that's where here we are going to claim persistent volume claim. And here we're going to use the option claim name. Just let me, I'm just going to open the other file to grab the name, because it was a long name, so we avoid those typos. Let's copy this. Let's get back in our pod. Yes, and we can save it here. PVC scheduled in node affinity. The affinity defined in PV affinity. Okay. Here, let me put here, it's not claim name, it's claim name. Let's save this file. Okay, so the volume is going to be requesting, that's how the pod is going to be requesting for persistent volume claim. Now we go into the terminal. We check the state of the cluster. We don't have any pods. SC means storage class. We don't have any storage class. PVC, persistent volume claims, we don't have any. Okay, so here, no, not like that. So here we're checking the persistent volumes. Okay, now we got it right. No persistent volumes. We'll be deleting a lot. So that's why I need to check. So we have the storage class here. Local storage. It is referenced here as a storage class name in the persistent volume claim. That's how it's going to be able to request for that one. The storage that we are requesting in terms of capacity is 512 KIs. And here we go, we check the PV, the persistent volume that you have created, just to have an overall view of the resources that we want to create for this first example. Okay, and here we have local storage also, storage class, which is referenced, and the capacity is matching the policy. The reclaim one is delete. Okay, the local pass, temp, local PV, and for the affinity, location Shizuoka. Okay, the provisioner, there's no provisioner. We use the option wait for first consumer just to see what's going to happen with this option. The affinity, we expect it to be on node 2. Okay. And here we use the storage class that we have defined here. Okay. So you got the overall look of it. Okay, persistent volume created manually with an access mode with the right ones. Add the pass, TMP, local PV. So the pod, the last resource, has the same volume mount, which is a TMP local PV, is requesting a volume, which is persistent volume claim. Okay. So we need to create the persistent volume claim first, because the pod is going to be requesting that. And that's how it's going to get its capacity of 512 KIs. Let's start applying those resources and fix any errors if there is any. Because normally you just go into the documentation, you copy and paste, you change what is needed to be changed, and it should work. Here we just did all manually in order to keep learning, and at the same time we might get some errors from doing it like that, but it's okay. Okay, no provisioner, reclaim policy delete, volume binding mode wait for first consumer. So the storage class has been deployed without any error. The persistent volume claim has been deployed. Let's get the persistent volume claims to see what are the details. The status is in a pending status. Storage class has been found. So it's linked to that storage class now. API resources, you see the PVC, what I was telling you earlier. It's a namespace resource. Here we're working in the default namespace. That's why you see I deploy it, and in the YAML file I'm not using any namespace, but it's a namespace resource. So if you don't use anything, it goes to default namespace. We make it easy, but it's good to keep this in mind. We deployed the persistent volume, which is in the status available. Storage class referencing the same storage class as the persistent volume claim. Access mode read write once, and the capacity 512 KIs. Okay, we got all the resources necessary to be present when we're creating static volumes. Now let's deploy the pod. Okay, I called it. I'm just going to create some other tabs so we can go in watch mode on those tabs and see what's going on. So I'm going to watch here the pod creation. Okay, so here we're going to be watching what's going to happen to the pod when we create it. I can create some extra tabs so that we can also follow up on the persistent volume claim status change. Okay, we stay in watching mode for that. So it's still in pending mode. We haven't done anything yet. We open another terminal in another tab where we're going to be following up on the persistent volume. Okay, so we got our tabs ready. Now we are ready, we can maybe do this. Okay, apply F, pod request storage. I haven't pressed yet, enter. So let's see what's going to happen. Okay, I pressed enter, but there is an error. Turn off, validate false. Pod request storage error, validating. Ah, there is a typo. API version not set. If you choose to ignore these errors, so you see you can ignore errors, but it's not going to work ignoring. So I'm just going to fix all those errors. Here is persistent volume claim with a E. Mount pass is not months pass, it's a mount pass. And the API version was missing the A on the top. I've changed it. I fast forwarded this part so you don't stay. Okay, here pending. Persistent volume have been bound to the persistent volume claim. So the storage class has been used in order to do this binding. After this binding is made, now the container is creating. It's not anymore in a pending stage. You can see here the pending also has changed to bind, and here the available is now bound also. This is still creating, so there might be something wrong. It should be running now. Let's keep going and check. Let's get the pods from here just to see how wide. Container creating. it has been affected to the node 2. So the affinity has been respected. So as you can see here, the affinity that you have set on the PV, persistent volume, have scheduled the pod in the right node to match this persistent volume to be together. This is because we use the option wait for first consumer. Okay. After we will check why the pod isn't running. Maybe it takes time, but at least this has worked. So when we use wait for first consumer, the scheduler is going to check where the persistent volume is going to be affected in terms of nodes, all the possibilities, and if the pod can be affected there, it's going to be affected there. So here I did maybe a mistake on the temp. So I described the pod and is missing the path. So we need to manually create the path. So I'm going to SSH to the node 2. If you're playing static, you need to create stuff by yourself. It's not automatic. So we're going to create the directory tmp local pv. Okay, we exit the node. I'm just going to show you here that it has been created. Okay, now it's present. So the pod couldn't be created because this path wasn't there on the scheduled node 2. So I can subscribe during the break. So let's keep going. Container creating. So now I might need to kill this pod and to restart it. So let's delete the pod. Okay, we wait a few seconds. The pod has been deleted. The volumes are still bound. Okay. Can we reuse those volumes like that? Let's reapply the pods to the cluster. And you see now we're passing pending to container creating. This hasn't changed. Nothing has changed. And now it might be running because we got the second one. That means that it's getting those volumes and now it's running. Amazing. So now you understand that you have to do all manually. You have to go on the node. You have to create those paths that you have a reference in your YAML files for it to run properly. Okay. So now what we can do, let's play with it a bit. Just see what happens. We can exec into this pod and open a shell. I'm going to use bash. Just let me do get pods running. Everything is fine. So now I know the name of the pod because I have forgotten it. It is written just above. Pod needing storage. That's why it's good to have auto completion. We use bash and now we're inside the pod. We're gonna be writing a sentence to a file inside that volume, persistent volume that you have created. Echo new Mangakisa storage created. TMP local PV, that's the path where we have this persistent volume. We're gonna put it in a file called Mangakisa storage status.txt. Okay, we can exit this pod and now let's SSH to the node 2 and check if this is present there. So was it successful or not, this static way of creating pods, persistent volumes? Yes. So we got it there, persistent. Okay. So we exit, we come back to our controller node, and let's delete those resources now. Important step, when you delete, is still bound. This, you've seen it already now. Deleting the pod wouldn't make those volumes available for other pods unless they reference those directly the same way. Okay, so we get the persistent volume here is in a state called bound. We delete the PVC, the persistent volume claim, has been terminated, and here has been released, and after has failed. So this is on purpose. Normally it should just stay on released if you have used the reclaim policy retain, but we use the reclaim policy delete, which doesn't work when you use a static way of making those persistent volumes. That's why I used delete from the beginning, so that you can see this straight away. And we will be keeping delete to the end of the video. Okay? So here I just delete also the persistent volume, and I say need to delete it manually. Will not be able to use it again anyways. Okay, so the persistent volume, if you use a delete and you're on a static mode, you need to delete it manually also. So just match in your head static with manual. You're doing everything by yourself. We're going to delete the storage class and have a little break to like and subscribe. Using empty storage class name. So we're going to use empty storage class name. Here I'm just going to get rid of volume binding mode. Wait for first consumer. And we're going to deploy this storage class. On the storage class now, you see the volume binding mode is immediate. Okay, well before it wasn't immediate because we had this option of waiting for the first consumer. So now it's not anymore wait for first consumer, it's immediate. And here what we're going to do, we're going to be going into the persistent volume claim that we had. We comment it out. And we create storage class name equal to empty string. Let's see what's going to happen if we do that. Let's apply the persistent volume claim also. Let's get persistent volume claim is in a pending mode. There's nothing to link it to for the moment. We're going to go into the persistent volume and do the same. We're going to comment out the storage class, local storage, and use storage class name as being an empty string. And let's see the behavior of the cluster and the management of storage. We apply it. So here we get the PVC. Persistent volume claim is still pending. We get the PV, it's bound. So it has been bound in the meantime, in the default has been bound to the persistent volume claim. Has been there were a little delay. So that's the same. So now they linked immediately. It doesn't wait for pod to be claiming for resources for persistent volume. Okay, so here we have a bound. So shall we deploy the pod? Let's just apply the pod from here. So we have all in the same screen. Has been created. Get the PVC. So the PVC now, I don't need to give the name, it's okay. That's autocomplete, it's bound. All good, but we don't see any more storage class. So even if there's no storage class written, it could match the PV because they're both having empty storage class. Deleting resources does not delete the node folder. You see the node folder still exists. Just to show you, I have been deleting. I just fast forward this part, but deleting the resources one by one, getting back using SSH connection, checking. Okay, so not using storage class on persistent volume now. That's the example. So when you're using static, the delete reclaim policy doesn't work. That's what it means basically. So you don't get on the node the path physically deleted. There is another one called recycle, but it will be deprecated. So that's why I'm not showing you, I'm not talking even about that one. So let's get rid in the persistent volume claim now. Now it's not matching anymore with the persistent volume storage class name referenced. Okay, so here we have a storage class name referenced. Persistent volume claim, there's nothing referenced. Here is referenced as an empty string. Before it was also referenced as an empty string in the persistent volume claim. That's why it could be matched, because they are the same capacity, read write once. So it has been matched straight away. So let's go here, we get rid of this. We're seeing different cases. So we see how the cluster react to it. That's the best way to understand how it behaves. Otherwise it's too confusing. You have something working once, and after another time you don't know why it's not working. It's because you changed something, which is very critical to the cluster. So we're going to apply just PVC, storage classes, and PV as we've done that before. We're going to do the pods straight away, just to see what's going to happen. Now we don't have any reference to any storage class name. Storage class is still saying immediate binding. So it's going to be binded or not? Yes, has been bound. Because they're both not referencing any storage class. So they're somehow matching. So if you get rid of storage class, they'll be bound immediately. You see, they're bound. No problem. Let's see the pod now. Let's get the pod. Is it running? Or is it pending? So I don't need the name. Yes, it's running. So it works without any issues like that. Okay. So here the lesson is that just make sure that in the PVC and the PV, the storage class names match. When they're not existing, they shouldn't exist in both. When they exist, they should be referencing the same to be able to be bound together. And inside the pod, we still have access to this file, as you can see, which hasn't been deleted. That's why we could read it from the pod, because it's scheduled in the same node, because it's following the affinity that we have set in the persistent volume. That's how we can tell that it has been bound perfectly. So now we are going to delete those resources. Please like and subscribe during the break. Using wait for first consumer class. So we're going to see another example here. Didn't have time to read the whole title, but you can pause the video and check it again. So let's keep going in our examples. So we're going to be now always using wait for first consumer. We apply the storage class, keeping that. We don't want immediate binding. We want it to wait for the pod to request for persistent volume. And at that time, we want Kubernetes to provide us with a persistent volume available. Okay? So here we put back storage class to the one that we have defined. As at the beginning of the video, just go back to what we've done before. Okay, go to storage class. We already know how it's going to behave like that. Okay, I just applied the PVC and the PVC spending, PV spending also. Apply the pod. So this has been bound. PV and PVC are connected. The pod has requested those. So they're not in the pending mode anymore. Okay, same here for the PV. We get the pod is running. We delete the pod. So as I've explained you before, the difference between delete and retain. So when we use delete, actually Kubernetes is assuming that we are using dynamic provisioning. So that's why I used it while we're doing the static one. So when you're using the static, just use retain. So here using delete, because of this assumption of having dynamic provisioning, when we release the persistent volume, it fails. That's what we've seen before. I have explained you, but I wanted here to just stop a bit, just to explain you why we've done that and why we get failed for the persistent volume. So at this time, it needs to be deleted manually. Wait for first consumer also implies dynamic provisioning. We've been using that. This implies that it's dynamic, that we are not creating those persistent volumes by ourselves. Okay, so when you're using static, just use immediate bounding and use retain as a reclaim policy. So now we're going to see the first default storage class and then work on dynamic provisioning. Please like and subscribe during the break. Default storage. So let's see the case of having a default storage. So storage class, we set up a default. So whenever there is a persistent volume being requested, the default will be used. This is no other matching. So from now I'm going to be changing those examples so that we can see how those bindings works. We're going to be using more than one storage class. That's why I'm just copying the initial storage class and I'm going to be just changing the name. So here, storage class 1, the storage class 2 is created from the one that we've done before. and I'm going to create another storage class, which is going to be called StorageClass 3. Okay, I just use the same name for the file. So it says no wait for first consumer, but it will be activated actually. There will be wait for first consumer. But this one, the third one, I'm going to be using a default annotation. This might be deprecated in the future, but at the moment, that's what is used. It works. So we are going to change this YAML file by adding in the metadata an annotation. So annotations, and here we're going to add the Kubernetes special annotation for that. StorageClass.kubernetes.io is default class. Okay, and we set it to true. Put true between quotes, otherwise you're going to get an error, because I got an error before because of that. Okay, and the provisioner, we're still working with the no provisioner. So I'm just going to copy PVC to here and also do the same. We're going to create more than one PVC. So for the moment on the storage classes I have deactivated the wait for first consumer, because we're going to be just working static for the moment, and after I'm going to be reactivating it later on in the next examples. So let's go here and create another persistent volume claim. Okay, persistent volume with or without storage class, .yaml. Okay, we need to update this one to change the name. Let's make it shorter. So I'm going to call it PVC, this I can keep it. Following node affinity from PV, maybe in PV. This is shorter and you still understand. With or without storage class. Okay. I'm going to be playing with the storage class here. Let's get rid of those so that we got only our different configs. So we're still requesting the same capacity. I won't change the capacity. We just check on the behavior of the cluster with those storage classes. Because here we're going to introduce the default storage class and we want to see what's going to happen. Okay, so storage class will be empty. Empty string. And the storage class name here, I say a special one. So in the other one, I'll be using a special storage class name, but for later on, not for now. So for the moment, we're going to be just leaving it like that. no storage class defined. We save the file, we go to the terminal. I'm forcing myself to use NeoVim, but I like Nano, so you'll see me just go in Nano like that from the terminal straight away. Okay, so you see there's no storage class. So PVC with or without storage class, we don't have any. I'm going to copy the persistent volume so that I don't need to type everything again. We're just going to be updating it. Okay, there were an underscore. Let's copy it to here. Let's change the name of it. Or shall I make more PVs? So let's move PV local YAML to PV local no storage class. Okay, I'm getting rid of those storage classes to see if the default storage class will be enabled. If it is enabled, would it be picked by Kubernetes for those? Okay, here same, a little bit of a cleanup. Now you got it, you understand how it works. Which options do we need or not? And this won't change. I'm going to keep the affinity the same. There's a storage class which is empty here, and we're going to keep it just commented out, so no storage class defined. We save the file and we go to the terminal. And there's the persistent volume. Same, the storage class is commented out. Okay, so now you have an overview. The file names are representing what is actually done, and I'm just going to copy those to create more of those files. So the first ones, we got rid of the storage classes, and let's have some variants. This one I'm going to call it the number 2. Okay, it will be the same, but I will just change let's create one more. So we got 3. Let's call it 3. But this time will be different from the other ones. There will be storage class defined, but has an empty string. Okay. So now we have 3 persistent volumes, 3 different options. We have a PVC, which doesn't have any storage class. I'm just going to copy the name so that I can use it in the pod. Copy the pod that you had before. We're just going to change this long name for the other long name that we have defined. Okay, and we will be using this pod as a deployment. Okay, now we are prepared, we are ready. Hope that in your side you could create your files. Let's apply those one by one and checking the cluster status change. That's the first storage class. So we don't use wait for first consumer as it says in the file, and one of those is having the default annotation, and you see here on the side it's written default storage class. So here I have deployed 3, but there's only 2 present, so there might be a typo or something somewhere, or I have defined the same name for 2 of those. So this one is called local storage. This one is called local storage 2 in the metadata. That's what I'm looking at. Okay, local storage. Okay, so this is wrong. The last one, the number 3, is called local storage as well. That's why the first one has been just updated with the annotation. Let's fix this. Okay, I delete the local storage. I'm just going to fix this naming just by making those 2 names different. So here it's going to be local storage 3. Okay. Now we're good. Let's redeploy those. You don't even need to delete the second one, just the first and the last one. But here we're just going to be doing those 3 together. Okay, now we have 3 of those, and the third one is the default one. You see now there's a little annotation telling us that it's a default. So the annotation that you have marked has worked fine. Now let's see how it's going to be with those persistent volumes and persistent volume claims. So here I'm going to deploy the persistent volumes. 1, 2, 3. Let's see how they are in the cluster. They're available. You see, I'm not using wait for first consumer. So when I'm going to deploy the persistent volume claim, it should be bound straight away. But let's see if it's going to be bound to a default volume or not. Okay, so this storage class, the first one, doesn't have any storage class name defined. Same for the second one. Okay, we got 2 of those without any storage class defined. And we have the third one, which we have a storage class defined, but without any name. We just put an empty string. Okay, the number 3, which is an empty string. Just a reminder. So we've seen those 3. They're all here, present in the cluster. Now let's apply the persistent volume with or without storage class. Okay, there were no storage class. They're still available. Hasn't been bound. And this is staying in the pending stage, but it has picked up the local storage. You see? So it has been connected to the local storage. The default one, the local storage 3. So if we apply the pod, let's see what's going to happen. Because it is pending for the persistent volume claim, the pod is also pending. If we describe the pod, let's see what it says. Default scheduler, 3.0 node available. Pod has unbound immediate persistent volume claim. So there's a persistent volume claim, but the persistent volume claim is unbound. Not helpful for scheduling. Okay, so it couldn't bound the persistent volume claim. It has picked up the default storage class, but the default storage class couldn't link it to any of the persistent volumes that we have created. Okay, so this is the pod requesting that persistent volume claim, which exists. So has been connected to the pod, but the pod, while describing, says there's an error. Because this PVC is pending, is going to be also pending as a pod. Let's describe the persistent volume claim. No volume, plugin, match, name, Kubernetes, IO, no provisioner. So you see now we got a new issue. Is assuming that is dynamic provisioning. And here we said no provisioning. So it says no plugin match. So I'm going to delete everything. As the default option works, but let me show you here. We keep storage classes. Nothing to change to those. So the storage classes are going to be the same. We don't need to delete the storage classes. I got rid of all of the other resources. Please like and subscribe during the break. And let's reopen this. Go back to those persistent volumes. Let me edit this one here, the 2. So those ones, they didn't have any storage class names. The number 3 had an empty storage class name. So let me edit the persistent volume claim now to match at least the one which is having an empty storage class, which is an empty string. Okay, so now the persistent volume has an empty string, has a storage class name. The storage class number 3 has also an empty storage class name, while the other ones, they don't have any storage class names. And let's experience that and see how the cluster is going to behave in this configuration. Is this going to fix the issue with the plugin missing? The fact that it implies and assumes that we are doing dynamic provisioning while we still working with manual persistent volumes. So we want to do static provisioning. Let's apply those to the cluster. All the PVs, so we get the same as before. We don't see any storage class picked up. Okay, so let's do the PVC now, and the PVC has been bound. Boom, straight away. But it hasn't been bound with the one we expected it to be bound to. So here we're going to see a very important rule that you need to know. It has been bound to the first persistent volume, not to the last, which has matching. You see, this one is not matching storage class, but we've said before, if it matches, it's going to be bound. But no, not in this case. Okay, so you see here we have storage class empty string, but here we don't have the storage class as an empty string. There's no storage class defined in this YAML file, but it has been bound to that one. While the storage class, the persistent volume 3, this one had a storage class name having an empty string, so matching, but it hasn't been bound. And here we don't see any storage class default being selected anymore. So what's going on? Let's apply the pod. Are we going to see another issue? No, the pod is straight away running so fast. So has been working fine. We delete the pod. We delete the persistent volume claim. We check. So here we know the status is going to be released and then failed because we're using delete as a reclaim policy. This is okay. So we get rid of it manually. So now we have only 2 PVs. So just let me use apply with a double P. There's only 2 persistent volumes in the cluster. And now it's going to be bound to the local PV3. So why is that? Let me delete the PVC again. Let's delete the PV, which is failing after having deleted it. Okay, so now we just have 1 left. Let's see, can it be bound to this one? Let's create the PVC again. Let's check. Yes, has been bound. So the rule is somewhere else. This PVC can be bound to any of those PVCs. So what is the underlying rule? Did you find it? Could you understand it? Could you see it? So I'm gonna reveal you what is very important to know by redeploying those persistent volumes and just showing you what element you need to focus on in order to understand what's the underlying rule in a static volume binding when they're all matching the capacity and the permissions. Read write once here, for example. We have those 3 back into the cluster. We put the PVC on, has been bound to the 3 this time. But you see here, 10 seconds, the edge. So you have to look at the edge. It's because it's the oldest. The oldest in edge means the first which has been created among those matching. So the earliest. Okay. I delete the PVC. Now we expect it to be bound to the one with 7 seconds, which is going to be the oldest. So I have deleted the PV, the local PV3, and now I'm going to reapply this PV. So local PV3 now is the youngest. I mean, is 2 seconds, so it's not the oldest in the cluster. Will be the local PV2, the one which is the oldest in age. So the PVC is going to be linked to local PV2. Okay, so you need to focus on the edge here. That's how it's going to be bound. If you have several different PVs, persistent volumes matching your claim, your persistent volume claim. So that's how it's going to be bound or not bound to those. So it depends the order in which you have manually created those. So that's static and creating stuff manually. You need to have control on everything and understand more different elements which are not managed by Kubernetes but by yourself. On the nodes, you need to make sure that the path is created, and you need to like and subscribe also during the break. So what's going on with Provisioner? We had an issue with Provisioner before, the plugin. That's why I prefer to do all in one video instead of making 3 separate videos, so that we can follow a kind of a story. We're going to redeploy our 3 YAML files. YAML for the storage classes. Okay. So PV no storage class 2 and 3. I just get rid of the storage class name for all of those. Because you've seen before, it doesn't matter. It's more about the edge. Let's get rid of the storage class name here also in the persistent volume claim. We apply the persistent volumes one by one. We apply again the persistent volume claim. Now we're going to see what's going to happen and understand the default is on local storage 3. Okay, all the PVs are available. Now you're expert on it, you know what's going on. PVC is pending, hasn't been applied. So Kubernetes assumes that provisioning should be dynamic, not static. Okay? Because no storage class have been provided. So in the persistent volume claim, I got rid of the storage class. Okay, you don't provide me any storage class. That means that it's dynamic provisioning, it's not static anymore. So applying the pod, everything's going to stay in a pending state. So if you get rid of the storage class on the persistent volume claim, the one that the pod is referencing to, if you don't have the right provisioner, here we're using no provisioner, you won't be able to use this assumption of dynamic provisioning. So all the persistent volumes that you have created manually, you assuming a static provisioning, are not going to work. So the pod will stay on pending state has no dynamic provisioning plugin is present. No dynamic provisioning mechanism is present in your cluster. If it was in the cloud, you would also need to install some drivers for that. Pod has unbound immediate persistent volume claim. Okay? Preemption is not helpful for scheduling. And if you describe the persistent volume claim, it clearly says that it has failed, no volume plugin matched. Okay, that's the same error that we've seen before, referencing this no provisioner that we have defined in the storage class. Okay, all the storage classes are referencing the same provisioner, no provisioner. Okay, just to see the overall state and why we get this error. So we need to get a plugin to activate that. So you understand what we're going to do next. Let's delete everything. So here I'm going to be going to find a plugin, and we're going to be installing that plugin to the cluster. So we're going to do this part, and after we're going to be able to see the second part of the video, which is the dynamic way of doing stuff. That's a good transition. Please like and subscribe during the break. Dynamic way, plugin, dynamic storage provisioning. So dynamic provisioning means that we do not need to create persistent volumes. So now you're done with the persistent volumes. You don't need to create them anymore. This is abstracted away. Kubernetes is going to take care of creating those persistent volumes on the fly for you. All you need to define is storage class and persistent volume claim. And the pod is going to be referencing that persistent volume claim. That persistent volume claim is going to be able to pick up a storage class, and the storage class is going to see the capacity needed to create persistent volume. Okay, so let's go. This is a beta, it's nice. So let's go for this one. So you need to go in internet. Let's get out of this. We're gonna go for Rancher. Rancher will be a good friend for you if you're using Kubernetes. You can even use Rancher actually directly to abstract everything away. And here you have the YAML files that you can apply to the cluster. This is going to install a storage class. Production, development. I just used the development one. And you apply it to the cluster. You're going to get some resources, roles, cluster roles, config maps. But we are interested in this, the storage class. What you would need to do, probably, I'm just showing you because I'm going to do it here. We're going to add an annotation. We're going to patch it to use this one as a default storage class. So we're going to patch SC storage class, local path, that's the name of it. After we use P to enter those arguments as an option. So you won't see it in the describe, but it will be updated when I'm gonna check in the cluster. We will see default written next to it. So we have metadata. Inside metadata, we have the storage class. So it's all dictionaries, key values. So the key metadata holds another dictionary having the key storage class kubernetes.io is default class. You've seen that before when I used the annotation. So here we just put in this annotation into that that new storage class that we have created using this rancher GitHub repository YAML file that we have applied to the cluster. I feel like there's something missing. So storageclass.kubernetes.io/is default class. I put the quotes around true, and I think I need to wrap it not here, just to say that it's an annotation. Annotations like that. Okay, I think now we're good. Yes, we patch, no trouble. Okay, so as you see, as you won't see it here. Where is it? Wait for first volume. Storage class is default. Yes, we can see it here. And now we have the little default between parentheses next to it when we get in the storage classes. So now we have the right storage class, which will be able to use the delete reclaim policy in a good way, and will be able to provision a dynamic provisioning of those persistent volumes. I mean, that's what we want. But we need to go through different steps to see what's going to happen, so that we develop a better understanding. So you need to play more with clusters by destroying it, by trying options, not putting options, and seeing what's going on, what's happened. So we're going to be here just changing the naming. And here I'm going to use topology. As you know, before we used affinity to have the scheduling, to have a control on the scheduling of the pods, where they go in which node. But now we're not creating manually those persistent volumes, so there's no more affinity, because the persistent volumes are going to be created by our dynamic provisioner that we have just installed. So here, let me just update the storage class for the new provisioner, which is the rancher.io local path. And after, we're going to be creating more storage classes. Okay. So now the local storage, the name local storage class is going to be using this provisioner. The volume binding mode, now we're going to use it, because when you're using that, it's assuming that you're using a dynamic provisioning anyway. Reclaim policy, we stay with our delete. So here you can use retain. If you use retain, the persistent volume created by this new provisioner will stay on the node, so you will have access to it to a certain path. And here, because we're not using affinity, because we don't have control anymore on the persistent volumes created, you can, on the storage class directly, use allowed topologies. Okay, so when we use the option volume binding mode wait for first consumer, this is going to be using the scheduler, which is going to be seeing these allowed topologies and checking which node is matching that. So matching label expression, having the key here house server and the value, we're just going to match the value. Sapporo, for example. Sapporo house. I'm going to put more options. So it has different options that you can choose from if there's several nodes with showing those options, so that you can schedule the pod, and it's going to be checking on the resources on the nodes, the request resources, the resource available, and it's going to be trying to schedule it at the best possible node. Okay, so here we're using, instead of affinity, we're seeing a new concept called allowed topologies. When you're using storage, you can use that to have a full control on where you expect your pod to be scheduled. If you're using wait for first consumer option, so the volume binding mode, if you're not using it, this might escape the scheduling, and at this time it won't follow the rule. The scheduling will be different then. That's what I got from the documentation. So I'm just creating more storage classes. Local storage 2. Here the key is Mangakisa activity, and we're gonna just list some different activities. So after that, when I'll be done with the storage classes, we're gonna go together and we're gonna label those nodes. So you see, we're seeing all the different concepts that we've seen before while learning about storage. I'm gonna be labeling those nodes using our Japanese different areas or activities in Mangakisas. Here, watch Naruto no sound, shock wave 2, massage, the massage share, or all free drinks. Okay, I'm just gonna copy this, and I'm gonna do one last one. Now that you are an expert in those matching labels, we can create more storage classes, having a little bit more complicated options. And after, we're going to control the way we're going to label the nodes in order to have an expectation in where we want those pods to be scheduled. Okay, and here I'm going to change this for just city. Let's stay in Japan for one, Tokyo. And for the other ones, let's stay in Asia. Two other amazing cities in Asia. First one, we're going to go to Vientiane. And next, we're going to go to Hanoi. Okay. So we're good with that. So now we are good with our storage classes. We have created 3 of those. I'm going to be going into the terminal, and we are going to just check those and use those to label the nodes. So before creating any other resource, we're going to be working on that. So let me copy also the other files. PVC with or without storage class. Let's change the name for PVC default. So we're gonna try to have something binded to the default storage class this time, as now we have the good provisioner with the gonna be able to fulfill the assumption of Kubernetes that we do in dynamic provisioning. So we will be able to have this default storage class being picked up, while before we couldn't, because we were using static techniques, while Kubernetes is assuming dynamic provisioning. Okay, so here I'm going to call it name default Japan PVC, persistent volume claim. Resources, we reclaim the same resources. Okay, and the storage class name. Now we can put a name here. Local path. So our local path was the one created when we have installed the Rancher provisioner. Okay, so this one, persistent volume claim, is going to be linked to the default one. That's why we call it default Japan persistent volume claim. So after, what we can do, we might create more persistent volume claims. So we're going to go with 3 in total. So let me here create another one called PVC Japan 2. We just change the name and the storage class name also. So Japan PVC 2, and the storage class name, we go for Japan Storage 2. So I might need to change the storage class names then, because I think I've said local storage 2, local storage 3. We'll see. So Japan PVC Japan 3. I copy and pasted, so this is pasted. I'm just going to change it for 3 instead of 2. And down there, let's do the same. 3 instead of 2. I can save this file. So you see all the resources that you need to create are storage classes and persistent volume claims. Okay, let me just put the name of the PVC Japan 2 is an underscore. That's it. And after, I might need to reconcile those names. Let's grab the pod. Copy default pod, copy it to here. The pod won't change much, just the name that is referencing to. So we might create more pods, maybe 3 pods. Let's see. Shall I check maybe? So let me edit down there. Default. So I'm going to be, I just needed a few seconds to decide. So I'm going to be creating 3 pods so that we have each binded to each storage classes that we have created. Now it's an easy one. We're going to get 1 pod calling 1 persistent volume, which is going to be calling 1 storage class, which is going to be creating automatically 1 persistent volume for the pod. Okay, so pod calling persistent volume claim calling storage class automatically seeing how it's going to schedule the pod and where using the topology, and use it to create the persistent volume at the same in the same space, in the same node, I mean, because we use read write once. There's going to be 1 node and all the pods in that node will be able to read. So here, because I'm using the pod, I can add an affinity on the pod also. So we used the storage class topology, and let's add here affinity node affinity. Because it's in the pod, we can't just put required. We put required during scheduling, ignored during execution. And we wrapped everything in an affinity. So affinity, node affinity, while before in the storage class we were using node affinity directly. Here we need to wrap it in an affinity key. So here we're just going to match expressions, and we're going to put here Kubernetes.io host names. Here I'm going to match it to the node names. Okay. So the default here, for example, I want it to be scheduled on the node 2. It's very strict, this. So it's just going to stay in a pending mode if it's not matching the storage class topology. But we're just going to make it match. I'm not going to do the example of a failure here. It's going to be a bit more smooth. So, the pod needing a storage 2. We do the same. I need storage 2. I don't even need to change those. Local storage 2. So whatever it's in the spec, you don't really need to change the names. Just the persistent volume claim is important to reference the right one that you want to link to. So this one we can link it to Japan PVC 2. In terms of requirement of node affinity, let's go for node 1. So after that we just need to create one more. Let me edit down there. Pod requesting storage 3.yaml. Okay. We do a little update here on the name. Same here. We just did copy and paste and we're just changing the naming. And here, let's put the controller node for this pod. Let's go to the terminal. If there's any errors, we're just going to fix those. That's how it goes. And when I was learning Kubernetes in the past, I really didn't like to follow those tutorials where everything is perfect. Because when I was running my examples, following those, I got so many errors. So sometimes it's good to see the different errors that you can get, even if it is a typo errors, stupid ones. Because you can be stuck for a stupid error also for a few days. This happens a lot. Okay, so here we have a storage class. That's the first one. Okay, let me just fix those namings very quickly. Requesting. This is just to make easy the auto completion, so it doesn't stop in the middle. On here, we can add maybe another option. You can say node 2 or node 1. Why not? Because it's a bit strict to say node 2 straight away. So that I can play with the labels. and show that the topology has been also fulfilled in terms of requirements, what we've put in the topology. Trying to cover a little bit what we've seen before. That might be complicated, but here we see why it is useful. Just think you have a different type of nodes, some having GPUs, some better for input-output, some having more storage or whatever, and your application are different applications needing some GPUs because they're running AI models, or some of the ones that need more input and output I/O. Some of the ones that need more storage and so on. So we're going to do the same here for the second pod, node 1 or node 2. And let's update the third one, which is normally the controller, or another node. Let's go for node 1. So they're going to be all in a separate node or all in the same. Let's see how I'm going to do it. Okay, so now we can do the cut of those files, matching. So here we have the storage class. We're going to check the labels because we need to clean up those labels. We're going to put the new ones just to not be confused. We have the location here. It says Shizuoka. That's what we used in the previous example. So we're going to probably get rid of it. Okay, so we start fresh. That's the node 2 location. You put a minus. We got a storage class. We got a matching pod to this storage class, which is the default one. Okay. Node 2. Sapporo. So this one I kept it at node 2. Instead, I've updated it. Just to make sure it goes there. So we don't need to confuse ourselves on labels because we're focusing more on storage. That's the topic of the video. So we're going to label the node 2 house server. That's the key that we have in our topology. And we're going to use one of the values, which is Sapporo house. Okay. We're going to use the Naha house, for example, for another node, for node 1. And we're going to use Tokyo house or Vientiane house for the controller node. Okay. So now we can really expect this one to go on node 2 because it's going to be fulfilling those two requirements. So same here. I went into the, so here we kept 1 and 2. And we're going to label Manga Kisa activity. So let's go for node 1 here. That we're going to make it a match. Manga Kisa activity equal to, and we choose any of those options that we have there. I'm gonna go for Naruto, I believe. Watch Naruto, dash, no sounds, Shockwave 2. Shockwave 2, okay. This is done. Massage chair, we're going to put this one in another node. Or let me put maybe read mangas, one which is not part of the selection, in node 2. And we're going to use massage share for the controller node. These small cabins where you can sit and have a massage share. So it's very nice while playing games or while surfing the internet. So we're going to go for the storage class 3. Okay, here city, and we have controller node or node 1 for the labels. So we're going step by step. We're going to make all those labels. We do it slowly so that we are not making mistake on those labels. So otherwise it's going to be too many mistakes everywhere. This video will never end. And we're just going to make it match, because what we want to show here is that how the scheduling works. So the controller node is going to be Vientiane in Laos. Tokyo in Japan is going to be on another node. Let's just pick the node 2. And the node 1 is going to be in Vietnam, Hanoi. Okay, so we got our labels. We clear this. So this is one way to view the labels, but I showed you another way with the option L, and with L you can make columns. So here we're just going to use the columns corresponding to different keys, so that we have a better overview on how those nodes are labeled. So house server, that's the first one, manga kisa activity, and the other one city. And you see here we have those columns, and you can see that the controller, Vientiane house, massage share, and Vientiane for the city. Okay? Naha house, Hanoi for the city, watch Naruto no sound, Shockwave 2. And here Sapporo house, read mangas, and Tokyo. Okay, this is done. Okay, apply. So let's start applying those resources now. Okay, what did I do? I'm creating storage class with topology YAML. Storage class in version 1 cannot handle the storage class. Strict decoding, unknown field, allowed, topologies, 0, match labels, expressions. Okay. So we need to go in that file and fix this error. I'm trying to understand it. Can handle the storage class strict decoding error. So the allowed topologies, match labels, expressions. Maybe it's the extra S. I think it's match label expressions. Let me check that. We're gonna nano into it. Let's get rid of the S. I have to do it in all of those files that we have created before. I believe that's the issue. Hope so. Bye-bye, yes. And now let's apply it to the cluster. And see if it's going to cry. Yes, it's going to cry. Same issue here. With the value. It's not value, it's values. That's where the S goes actually. So let's get back to it and update this. And we should be good to go. And the first one. Okay, at least we're failing fast. So it's not letting us deploy something which is wrong. Which is good, so we can fix it before getting into the cluster. So now they deployed into the cluster. Not this. SC. Okay, now we're good. So we got the 3 that you have deployed plus the default one, which has been there because we have created that one when we have installed this dynamic provisioner. You can use another one. So get rid of the annotation on local path and put the default annotation in one of the storage classes YAML files that you have created. You can do it like that also. So you have control on which one is the default one. Okay, so I've created the default PVC. I've created the PVC Japan 2 and the Japan 3. So there's no PVs. We have the 3 PVCs in the pending mode. They're all allocated to their own storage class. The default storage class have been picked up by default Japan PVC, so the local path, and the other ones the same. So they have picked the right storage classes because we have indicated those in the YAML file. All good for now. Local path. Okay, so that's why it has picked here the storage class local path. That's how we have defined those in the YAML files. I just delete the default one. Just to show you, I get rid. So there's no storage class anymore defined in this PVC default. So that you can see what's going to happen. Boom, it has picked up the local path, which is the default storage class. So now the dynamic provisioning works fine. What we expect to happen is happening. We have defined an annotation saying what is the default if there's no storage class defined, and it has picked up the right one. So now this storage class will be able to be used for the provisioning of any persistent volume. Okay? So now we're working with a PVC without any storage class defined, which is handled by the default storage class that we have installed in the cluster. So here the pod 2 claim name default Japan PVC. I'm going to deploy it. So it should be Japan PVC 2. But I'm asking for the default. It's in a pending mode. Okay, so I go for node 2 normally. Has been scheduled in node 2 and now is running. Okay, so there's a bit of a delay for the scheduler to pick the right node. But let's check those files. So that's not this. We need to check the PVC default. Okay. Default Japan PVC. local path. There's no storage class defined. But we've seen before that this persistent volume claim has been allocated to the default storage class. So here the affinity have been followed. There's no topology involved because in that one there's no topology defined. So the affinity has been respected. We're in node 2 and the default is the one used. Okay. So when we describe this one, we can see the annotation true for the default here. Okay. So now we can review the logic. We get the pod, the claim is on the default persistent volume claim. Persistent volume claim which is not claiming any storage class. It has been bound to local paths storage class. You see here, which is the default one. Okay, and that's for the second one now. Let's check what's going to happen. The pod is referencing to this Japan PVC 2, node 1 or node 2, that's where we expect it to be scheduled. But the manga kisa activity, watch Naruto no sound, it's on the node, it's one of those nodes. And the other one is having another value that doesn't exist, it's not part of this list. Okay, so we check manga kisa activity on the nodes, and we can see node controller node has massage share, but is not node 1 and node 2, and node 1, node 2, only the watch Naruto no sound shockwave 2 is matching. So we expect it to be scheduled on node 1. Okay, the node 2 has another value, read mangas, so it shouldn't be scheduled there. We apply the pod. We wait, it's pending, need time. We wait, we check where it's going to be scheduled. So the scheduler is just going to take his time, because now it's going to be working with this affinity. On the other side, it's going to be working with the topology. We wait and we see if there's any error. We're going to be describing and fixing the error. So let's describe the pod and see why it's taking so long. 0 available. Unbound immediate persistent volume claim. Okay. So there's an issue somewhere here. So let's see. Yeah, it's still pending. So in fact, there is an error. We check here. Is not being binded, so there's no connection. Japan PVC 2. But is it the right name inside the YAML file? So let's check that YAML file. Japan 2. Japan storage 2. You see here it's called local storage 2. Yes, so that's something that I needed to reconcile before, but I didn't reconcile, and now you can see what's happening. So it's just gonna stay in a pending mode. So let's do it. Let's reconcile it. So we're gonna get rid of this storage class 2. We're gonna update the name of it. So the 3 will be the same, because the 3 also had to be called Japan storage class, storage 2, storage 3. So let's copy this. And let's go in and change change this name. Okay, Japan storage 2, this is good. We do it for the 3. Perfect. We redeployed. You see, we have just updated and redeployed. Delete, redeployed, has been bound. So that means that we have fixed it. And the pod was waiting. And now the pod is satisfied, which is perfect. Okay. So let me do the next one. The number 3. Okay. So here, controller on node 1. And we have the topology. Let me just clear this page, because we want to see where are the pods. Yes, we got it on node 1. That's where we wanted it. I mean, that's where we were expecting to have it. Using our labeling techniques, scheduler has satisfied our requirements. So we got a control net. Even if the persistent volume is created automatically, we still can have this control. Okay, that's what we got. Mongoose activity and node 1, node 2. Which column shall I call here? The Mongoose activity. Okay, just to show why is it there, is because we have it labeled Watch Naruto, no sound, shockwave 2. I'm repeating, but because we got an error in the meantime, it's good to repeat. We just check again, and that's the reason why it has been scheduled in the right node. Okay. Node 1, Watch Naruto, no sound, shockwave 2. Very important. Okay, we're good with this clarification. Let's keep going. We're going to be now just showing the last storage class, doing the same, what we expect. The city, we have 3 different cities. Those 3 cities are not present everywhere. I'm just going to show here straight away which cities: Vientiane, Hanoi, Tokyo. Okay. So it could be scheduled in any of those following this topology, but at the pod level, we gave it just the choice of controller or node 1. Okay? Here, controller and node 1 are part of those values. So it could be going in controller node, or it could be going into the node 1. So here there is choice. While before we have restricted those, now there is choice for them. Topology, I just got rid of this. Topology, I'm just going to open it. And get rid of the options, because I want it in the controller node. Okay, it's going to go to Vientiane for sure. So now only the controller node has this. Topology matching. So let's go for the pod. Let's get the PVCs. It's still pending. So there might be a delay. Wide. We check the pod. It's not yet scheduled. So we need to check the affinity of the pod, the resources, availabilities in the nodes. And after, what are the choices? The topology defined in the storage class. Let's describe the pod, check if there's no errors, as we've done before. Oh, there is an error, did not match the node affinity selector. Okay. Claim name, default. I know why. Let's see. Let's keep doing the troubleshooting as it should be done. Number 3, because we're claiming the default PVC. So in the default PVC, delete the pod. We delete the pod 1 and the pod 3. Let's show the persistent volume claim 3. Okay. It's referencing Japan PVC 3. So here we're going to change this for Japan PVC 3 so that we get the right one. Okay. And the 3 pods are running now. And they've been bound. So we just needed to claim the right one, and we are in the controller node as expected for the storage tray. So we were referencing the wrong persistent volume. Now I'm going to delete this pod 3. Delete the storage class. I'm going to go back in this storage class. Okay, so should be only controller node. That's how we got it there. So we're going to check if it is not matching. Let's see what happens when we have a different affinity defined with a different topology on the top in the storage class. Here we have different node affinity. So one is saying go to the controller because of the key and value. And the other one is saying affinity required to be on node 1. StorageClass have been deployed, and the pod 3 have been deployed. Let's see what's going to happen. Let's check that cluster. Get PVC. Bound. This says bound. Okay. But the pod is pending. But the PVC was bound before. That's why it just stayed bound. We don't know. Okay, the pod again, same status. Now we're gonna troubleshoot. Let's describe it. Okay, what is saying? Didn't match pod's node affinity selector. Okay, 0 nodes available. Preemption, not helpful for scheduling. Okay, so the scheduler check the topology. The topology is not matching the node affinity. They both direct the scheduler to different nodes. So the scheduler is like, okay, so just stay pending until you decide where you want to go. So it's not going to work. So here, let's go to the storage class. Let's delete the storage class. Okay. That's not the right one. Number 3. Yes, that's the one. And let's give it the option now to go to the Tokyo, which was the node 1, I believe. Something like that. Get nodes. Just let's check using our columns. City. Node 2. Okay, so that's not the one I want. So we put Hanoi. Because we want it on the node 1. We want it to... we have the choice of node 1 on the affinity of the pod. Still pending. Still pending. If it is pending too long, we need to troubleshoot. So maybe it needs more time. No, it's been a while now. I'll delete the pod. I'll reapply the pod. Okay. No. Just wait a few seconds. Or we describe. And we see that there's nothing available. It's not much the affinity. But I have changed the label on the storage class. So what's going on? Okay. The cities. So I need to get the nodes, not the pods. Okay, node 1 is Hanoi. So it should go on node 1. Hanoi, I didn't do any typo. Node 1. What about the pod? It says node 1 also. Okay. PV3. Get PVC, they're still bound. Not released. Get pod. Okay, we have the PVs. Those are the ones automatically created by Kubernetes. Okay, we see that Japan 3 is with storage 3, Japan 2 is with storage 2, default is with local paths, which is the default. So I'm going to delete the persistent volume claim because we don't get any update in the cluster. Has been released. And the PV, you see, it has disappeared after. While before we used to see failed, because it failed to delete because we didn't have the dynamic provisioner. But because now we have the dynamic provisioner, it could delete it. Let's reapply this persistent volume claim. There's no PV yet created. It's pending. Because that's the other step of checking. The PV might tell us what's going on, or it might just link everything again. No persistent volume created. For the moment it looks bad. There's something wrong somewhere. All the storage classes are present. Let's keep going slowly in the troubleshooting and we're going to find what's going to happen. So now it's time to describe the PVC. It's going to give us some secrets maybe. No? Let's see. So the PVC we want to describe is Japan. It's not PVC. Yes, Trish. Waiting for pod needing to be scheduled. You see? So it means that it's going to take some time to schedule. The scheduler is still checking the cluster because there are resources already deployed, so it needs to check more different stuff. Resources available. Need to check if there's any toleration. You need to check everything before scheduling the pod. So here has this waiting for pod to be scheduled. Maybe we need to delete the pod and recreate it because the PVC has failed before, but we got an information from it. Let me describe the pod. No. You see, the pod now has been scheduled. Since it has been scheduled, and we can see it has been scheduled in node 1, the one that we expect it to be in, now it should be fine. Yes, and now it's running. So sometimes doesn't mean there's an error. It means that you have to wait because the scheduler have more work to do, more checks. That's why we use wait for first consumer, so that it doesn't escape the scheduling job of checking for resources available and picking the right node. Okay, so here there are more rules involved, using affinity, using dynamic provisioning, and we're using also topologies. you've been patient. You've been going through those troubleshooting phases with me. If you didn't do any typos, you've done less troubleshooting, but it's good to see those errors, because you might get those errors just because of a little typo, but you, because you're an expert of Kubernetes, you're going to go into more complicated issues while it's just a typo. So in the road of mastering Kubernetes, you need to pass through those errors first. Okay? So I deleted the pods, delete all the different PVCs, and the storage classes. So here I'm going to comment out volume binding mode, wait for first consumer. Okay. The wait for first consumer means there will be a lot of checks done. So it might take time to get those pods deployed into the cluster. So now we are going to recreate the state of the cluster with those new settings. So we should be immediate, you see, immediate, but wait for first consumer stays on the default one, okay, because we didn't patch it. But for the other ones, we have an immediate bounding. After the storage classes, what you need to deploy is the persistent volume claims, not the pods. Okay. Sometimes it does that in my NeoVim. The cursor just disappeared. See, now I can't see it anymore. So they stay in a pending state, that's normal. Apply the default. So there weren't any persistent volumes created, even if we have immediate. So unless we request those resources, the dynamic provisioning won't create any persistent volumes. So no, that's not what I want. PVC, still pending. The pod is also pending. So when you're using dynamic provisioning, you need to use all the different options for this assumption. And using wait for first consumer, this is part of the options that's assuming that you're using dynamic provisioning. As I told you before, when you're using the immediate one, this is more for the static way of doing that. See, I applied another pod, has been bound to the default. Why? And is running because the default has the wait for first consumer, while the other ones are still having the immediate binding mode, because we have commented out on our custom storage classes the volume binding mode option. So let's deploy the other pods just to see. Override. Those are staying in the pending mode. Okay. PVCs pending, same. Let's describe. Okay. External provisioner. Failed to provision volume with storage class 2.2. Configuration error. No mod was specified. So you see, it's mandatory to specify the volume binding mode. Okay. After here, it's telling us to check. But that's the same for the other one. You get the same message error. So it's just telling us that the probable errors, those are good warning messages, because one of those is true. It's because we have deactivated this volume binding mode, which is required. So I don't need even to go to the documentation. It's just by trying here in the cluster that I know this is a requirement. It's a must have when you're using the dynamic provisioning. Okay, so you won't forget it because you used it and it didn't work, and you got to read the message, the error message, so now you know what you're doing. Next time you know that when you're using dynamic provisioning, you'll be providing this information. Okay, no persistent volume claim. So after here you get the same error and bound. So nothing has been created automatically by the dynamic provisioner. So that's normal that there's nothing for the persistent volume claim to be bound to. Okay, only the default one has been bound because it has the wait for first consumer. Okay, and those are gonna stay until the end of the times on a pending mode. So that's the way you're gonna be spending a lot of money on a cloud cluster, having pods which are not being bound to any volumes, and you're gonna be paying for resources that you're not gonna be using, and the users are not gonna be satisfied because the cluster is gonna be limited. Now let's put it back. Let's put it back to normal. So you're the administrator, you've seen this error, you come, you just update this. For you it's very easy. Now you understand how it works. Bound. Just updating that. Has been bound again. So it takes time, but at the end, all the different persistent volume claims have found their storage class to creating a persistent volume automatically, which the pod can now use. So the container inside the pod can run because the volume mount is existing. Okay. Let's go inside the pod. We haven't done that using those volumes in a dynamic mode. So the ones created by Kubernetes automatically. We go in the storage, in the pod needing storage 2. We're using bash. We check, there is a temp local PV available. Yes, there is a temp local PV. Okay. So let's see the behavior of this read-write once. We said that all the volumes are going to be written to one node. Let's see if those are going to be available to other pods running in the same nodes. Storage 2, pod needing storage 2 and pod needing storage 3 are running on node 1. So that's why we're going to be playing with those two and see if one can see the message of the other. How is Hanoi, mate? So mate message txt. Okay, so this doesn't work. I can't use this command. Why? Should work normally. I don't see where is the error. Event not found. Okay, it's because I used the question mark. Okay. Let me go in the folder directly. Let's copy this sentence. I don't see my cursor. Don't know where am I in the sentence. Mate message, okay. Okay, so I need to escape those characters, otherwise it's not gonna work. Let's just make the file. Touch, and I'm gonna echo the sentence without those bash blocking characters. How is Hanoi, mate? With a lot of W's without question mark. Okay, now we're good. Let's exec in the pod needing storage 3. Let's go in the temp local PV. No, so I can use ls_la with a little dash before, ls nothing. So I don't see the file that I've created from pod needing storage 2. So do you understand what's going on? Is that when you have those pods running in the same nodes, they're using read-write once, means they can write and read in the same node, but doesn't mean that they have access to each other's volumes. You know, that one has access to the other volume. The volumes might be separated. That's why here we can see the path temp local PV when we're entering in those two pods, but we can't see the file of one in the other while they're using both the same path. Why that? So here I'm going to write another message from Hanoi storage 2, but it's a storage 3. Still, please like and subscribe during the break. So, I explained you, but I didn't show you anything. So this is another day. So I had to redo everything just to show you. that you see here in TMP folder, there's nothing. There's no local PV here. Because we're using a dynamic provisioner that you have installed, you need to go in OPT. OPT, there is a folder called local path provisioner. And here you will find, you see default PVC 3 and 2. And that's how you can see those are the dynamic persistent volumes which were created. And here we can see the message mate txt. Only in the other one we can see the other message, but one pod doesn't have the access to the other pod's volume. Okay. So those are the persistent volumes which has been created. Even if the Japan PVC 2 and Japan PVC 3 are in the same node, they're not accessible to the other pods. So we're going to delete the pods. I'm just going to tear everything down so you see that what's happened to those volumes physically in the node. So the idea here is that we have created everything. We have created a file in those persistent volumes. We have a reclaim policy, which is the delete reclaim policy. So the persistent volumes, we expect those to be deleted. But as those are being deleted physically on the node or not? So here I got rid of the persistent volume claims, even the default one. Okay, we're back. We have one persistent volume has been released, but in a second disappeared. So the cluster is not showing those anymore, but are those present on the node? So let's go in the node 1. We do an SSH again. We go in OPT folder in the local path provisioner, and we check and there's nothing in. So it's actually got rid of those physically also. We have seen static provisioning by creating our own persistent volumes. We have seen the annotation to set up the default storage class, but we have seen that we need to activate a plugin in order to be able to deliver some dynamic persistent volumes, this time created automatically by Kubernetes. We have used the reclaim policy delete and have seen that it is assuming dynamic provisioning, active only when we had that activated at the end. Before that, it couldn't delete, but at the end it could delete the volume on the node path. Having one video with lots of examples like that is precious. I didn't cover all edge cases, but you will survive well with this understanding. You can play with it a little bit more on your own. The video would be too long otherwise. Next, I already know what we are going to check. We're going to see backup and restore. Very important. If you have SLAs and SLOs constraints, we will see. Okay, let's stop here. Hope that you liked this video. Please like and subscribe, and see you next time.